Hello everyone, I am Aranas, 18 years old and currently studying here at Benedicto College, Cebu City campus as a grade 11 student. And so for today, our agendas are we have topic 1 and topic 2. So for our topic 1, we will be discussing all about discrete and continuous random variables. And for our second topic, it is all about discrete probability distribution. So first, let us talk all about discrete and continuous random variable. But first, let us know what is discrete. So discrete are variables that cannot be defined in decimal and fraction form. Or in other words, it can only be defined as a whole number. Now, let us know what is random. So random means chosen without method or conscious decision. For example, picking a student in a classroom. So when you pick a student, you are not specifying which student it is. And that is an example of a random. Why? Because you are picking a student without conscious decision. Now, let us know what is variable. So, variable has different meaning in mathematics, but in statistics, a variable defines as your data gathered. So now that we have learned what is discrete, what is random, and what is variable, let us now move on to knowing what discrete random variable is. So the definition of a discrete random variable states that one which may take an only countable number of distinct values, such as 0, 1, 2, 3, 4, and so on. Discrete random variables are usually, but not necessarily, counts as what we've learned about discrete, how it can only take on whole numbers and cannot be defined as fractions or decimal form, your discrete random variable is your data gathered that can only take on whole numbers. For example, so our first example for our discrete random variable, A, the number of students in a classroom. So when you talk about students in a classroom, it is an example of a random variable. Why? Because you are not specifying which students they come from. Are they from the junior high levels, senior high levels, or in college levels? Well, it is also an example of discrete random variable because when you talk about the number of students, you are referring to people, and people cannot be counted as half. They cannot be counted in decimal or in fraction form. So now for our second example, the number of teachers in a faculty room. This example is just the same as our first example, but now we are talking about teachers. So the number of teachers, it is an example of a discrete random variable. Why? Because teachers are person. And person or people, you cannot count them as half, decimal, or in fraction form, which is why it is an example of a discrete random variable. So now that we are done with our first topic, let's move on to our second topic, which will be all about continuous random variable. So what is continuous random variable? Continuous data refers to data that can be measured. Height, weight, temperature, and length are all examples of continuous data. In contrary with our discrete random variable, continuous random variable are your data gathered that can be defined in decimal or in fraction form. So for us to fully understand what continuous random variable is, I have some examples here for you. So for our first example, a person's temperature. So when we talk about temperature, a normal person's temperature is 37. But when it reach maybe like 37.5, you may have a slight fever. And that in itself is an example of a continuous random variable because a person's temperature is continuously increasing. So for our second example, we are talking about a toddler's height. So again, when we talk about height, that's measurement. So we're going to find out a toddler's measurement of his or her height. And that in itself is already an example of a continuous random variable. So for our third and last example is time of a person that he or she can hold his or her breath. And for this example, we will be measuring the time. And time can be measured as seconds, minutes, or even hours. But when we time a person, it stops at a certain time. And even milliseconds will be counted. And that is defined in a decimal form, which is an example of a continuous random variable. Okay, so now that I have done my discussion, let us now test your knowledge if you really learned something with I discussed earlier. So I will be giving you 5 activity that you will be later answering. And we will be checking your answers to see if they are correct. So are you guys ready? So let's begin. So as you can see on the screen, I have given some examples of random variable. So what you will be doing is to classify whether these random variables are continuous or discrete. So you can pause this video and resume it after you're done answering. So now let's check your answers to see whether they are correct. So for our first example, we have score in an exam. So the answer is discrete. Why? Because when we talk about score in an exam, even though it is sometimes written in a fraction form, but the total score or your total correct answers will be counted as a whole number. And that is an example of a discrete random variable. So for the second number, it has weight of a person. Again, when we talk about weight, it is measurement. And when we measure something, it can be sometimes defined in a decimal form. So when we talk about decimal, it is continuous random variable. For our third example, we have employees of a company. So when we talk about employees, there's a person, and you cannot count person as half. You can only count them as one for each employee. So that is an example of a discrete random variable. So for our fourth example, which is all about amount of water an athlete drinks a day. So the exact amount of water an athlete drinks a day maybe can be defined into 4.5 milliliters or liters a day. And that in itself is an example of a continuous random variable because sometimes it can be defined in decimal form. And for our last number, the number of paintings in a gallery. So the number of paintings, even though the paintings have different sizes, but we're talking about the total number of paintings in a gallery. So we can count them as one painting per each. And that is an example of a discrete random variable. Okay, now let's move on to our second agenda or our second topic, which will be all about discrete probability distribution. But first, let us know what is discrete probability distribution. So discrete probability distribution consists of the values a random variable can assume and the corresponding probabilities of the possible outcomes. So I will be showing you some examples, okay? So if you toss 2 coins at once, the possible outcomes are heads, heads, head, tails, tail, heads, and tail, tail. If x, the random variable for the number of head. So as you can see right here, these are the possible outcomes when you toss 2 coins at one. So there are four. It consists of heads and heads, head tails, tail heads, and tail tail. So for this example, we'll be focusing more on having a possible outcome which is heads. And when we write this, it should be in organized. So either from highest to lowest or lowest to highest. So with this, we started from 0 at the top to number 2 at the bottom. So to explain the sum of all our possible outcomes, we have 1 over 4 if x is equals to 0. So you might wonder, why is there 1/4 if there are no heads? Because in the example, you can see that there is tail and tail, which means that no head came up. So which is why 1 over 4, or meaning that out of the 4 possible outcomes, a head did not come up once. So for our next possible outcome, we have 2 over 4 if x is equals to 1. And here you might wonder again, why is it 2 over 4? Because as what you can see in the example I have given earlier, the number of possible outcome where only one head came up are twice. So that's why it is 2 over 4 possible outcomes. And for our last possible outcome, we have 1 over 4 if x is equals to 2. So in here, why is it 1 over 4 when there's two heads that came up? Well, that's because out of all the 4 possible outcomes, the result where two heads came up only resulted once. So that's why it is 1 over 4, or out of 4 possible outcomes, only two heads came up but only once. So as what you can see on the screen, we put it in a table form, which our possible outcomes are the heads and heads, head tails, tail heads, and tail. And for the next, or the other side, has the value of the random variable of x, or the number of heads. So now that we are close to end our video, so I have a little bit of an activity for you, but it is up to you whether you answer this or not. But if you'll be answering it, then good. So you can test what you have learned with my discussion. So this is just easy, and it is just the same as what we did earlier. So now we're at the end of the video. I want to thank you guys for watching and listening. I hope you have learned something with the discussion. And again, thank you for watching and have a great day.